One of my students is working through some integration questions, and she wanted to know with regard to inspection. She asked, I know that we have to create the derivative, because remember in inspection you create the derivative if you don't see it there, the derivative of the inner function. She says, but why can't we just integrate immediately? And what she means by that is just add 1 to the power and divide by that number. In other words, why can't you just use the power rule? Why do you have to create that derivative? So here's the solution. And this is the solution done with the whole idea of creating the derivative. We see a composite function. Inspection says you need to see the derivative of the inner function. So I've got 3x minus 4. The derivative of 3x minus 4 is 3. So we create that derivative so that we see a composite function and the derivative, and we compensate for timesing by 3 by timesing by a third, or dividing by 3. So in essence we haven't changed anything. She wants to know, why do you have to do that? So let's do the problem without doing that and see what happens. So let's say we just wanted to apply the power rule. So here's my question. If we just apply the power rule without adding in the derivative, I would have 3x minus 4 to the power of 6, and I divide by 6 to compensate, and I add my constant of integration. And then I'd be finished. Or that 6 can come out in front, just like I did here. So in order to test that, we're going to go the other way around. Remember, the opposite of integration is differentiation. So let's see what happens if we take this function and differentiate it. So I want to find the derivative of that function. So if I've got, let's say, let's go that my function is 3x minus 4 over 6, and that numerator is to the power of 6. We're going to ignore the constant of integration, because if we differentiate that, it's 0. Let's differentiate that. Now, to differentiate, we would need just to take that, let's take that out, 3x minus 4 to the power of 6. When we differentiate, the 6 comes to the front, so the 6 would come to the front, we divide it by 6, it cancels, and I would subtract 1 from the exponent, so that's to the power of 5. But remember, chain rule says you must go inside and differentiate that, and the derivative of 3x minus 4 is 3. So I could just write that as 3x minus 4 to the power of 5. So in essence, if I had differentiated correctly, then, and if I had integrated correctly, then what I land up with here should be my original function. However, can you see there's a difference? This function doesn't have a 3. This one does. This one has a 3. And the reason why it has that 3 is because of the chain rule. You have to differentiate what's inside those brackets, that inner function, to get the 3. But because my original function didn't have a 3, that's why I introduced that 3 and times it by a third to compensate. Because if I had a third in front, then that 3 and third would give me 1. Oops, it would give me 1. And then it wouldn't be there. That's why we have to introduce that derivative, because when you go the other way around with the chain rule, suddenly it appears. So I hope that answers the question.